While mid-rises have become relatively common in timber construction, high-rises are more scarce. They represent a unique set of opportunities. But despite the promising aspects, tall timber construction isn't without its challenges. In this case, the preferred structural systems vary from post and beam to panel and solid timber constructions, or a hybrid combination of both. But when it comes to high-rises, the post and beam system isn't as straightforward as in shorter structures. The beams often have to be reinforced with steel plates or high-strength tension cables to withstand the increased load and height. One key difference lies in the building's weight. High-rises are designed to withstand considerably more load from both the building itself and external factors like wind. High-rises often employ specialized structural systems to ensure stability. Additional lateral bracing is often used to counteract wind forces that high-rises are exposed to. These can include shear walls, diagonal bracing, or even tuned mass dampers in some extreme cases. Fire safety takes on a new level of complexity in high-rises. Very tall buildings have to be designed in such a way that there is a very low probability of fire spreading to upper floors and a very low probability of structural collapse at any time during a fire, regardless of whether or not the fire can be controlled by firefighting services and suppression systems. In high-rise timber construction, engineering for wind and seismic forces is a major consideration. The taller the building, the more significant the wind loads, which can cause vibrations or even structural instability if not correctly addressed. Advanced simulations and material testing are essential for ensuring stability. Let's have a look at some case studies. Treat, a 14-story timber apartment building located in Bergen, Norway. This structure stands as an excellent example of what's achievable with modern timber construction methods. In Treat, the assembly and structural systems are interlinked in an unconventional yet effective manner. Prefabricated building modules are stacked in groups of 4 stories each. These modules form the internal part of the building and are entirely self-contained. But they are not doing the heavy lifting. Instead, the external glulam trusses, or the exoskeleton, take on the main load-bearing responsibilities. Once a stack of 4 modules is assembled, the exoskeleton is built up to receive and bear the load of the next set of 4 modules. The fire strategy for Treat is carefully crafted. The main load-bearing system is designed to withstand 90 minutes of fire exposure, going beyond the usual 60 minutes for secondary load-bearing elements. The 90-minute fire resistance is crucial because it ensures that a fire starting in any apartment will die out before spreading to other parts of the building. Beyond structural fire resistance, Treat incorporates various other fire protection systems, such as a sprinkler system. Elevated pressure in escape stair shafts helps in containing and controlling the fire. All exposed timber surfaces in escape routes are coated with fire-retardant paint, and gaps between structural elements like beams and columns are sealed with fireproof joint filler. Let's examine a real-world example that encapsulates this principle. Mjøstarnet is an 18-story mixed-use building located in Brumunddal, Norway. The main load-bearing elements consist of large-scale glulam trusses along the facades and internal columns and beams in the building itself. In terms of vertical loads, there are 22 columns with a maximum cross-section of 625 millimeters times 1485 millimeters. These columns transfer the vertical loads from the beams and diagonals to the foundation. These trusses brace the entire building, giving it the necessary rigidity to handle horizontal deformations and dynamic effects. Mjøs Tornat utilized a groundbreaking assembly technique that involved transporting individual pre-processed timber elements directly to the site, bypassing traditional trial assemblies. This method proved highly effective, resulting in only one fitting error among hundreds of large glulam parts. The approach expedited construction, minimized cost, and demonstrated remarkable precision, with most structures installed within a 10 mm deviation. Let's take a closer look at a cutting-edge project that exemplifies high-rise timber construction. The Sara Kulturhus in Skellefteå, Sweden, by White Arkitekter. This 20-story structure is one of the world's tallest timber high-rises, featuring an array of cultural and commercial spaces. The structure of Sara Kulturhus is a masterclass in hybrid construction. The low-rise portions of the building use glulam columns and beams, along with CLT shear walls and floor slabs. The high-rise portion, however, utilizes prefabricated CLT volume modules, stacked between two CLT lift cores. The design succeeds in eliminating the need for concrete in the load-bearing structure. In the image, you can see this process of the volume models being placed between the CLT cores. As technology and regulations evolve, we can only expect to see more high-rise timber buildings that challenge our traditional notions of architecture. Tall timber refers to timber buildings that go beyond the established high-rise standards. Generally, a high-rise building ranges up to about 30 stories. Anything beyond that, constructed primarily with timber, falls into the category of tall timber. This term is pushing the boundaries of what is traditionally considered possible with timber construction. Now let's journey down under the Sydney's K Quarter Tower by 3XN, a marvel in adaptive reuse. This 49-story structure stands tall at 206 meters and offers 89,000 square meters of floor space. The tower retains 65% of the original AMP Center structure, including beams, columns, and slabs, and 95% of the original core. This effort saved an astounding 7.3 million kilograms of embodied carbon. The W350 plan by Sumitomo Forestry and Nikken Sekkei is a glimpse into what the future could hold for tall timber structures. Scheduled for completion in 2041, the project aims to construct a 350-meter tall wooden building. This effort underscores the ongoing research and long-term vision that industry leaders have for the future of timber construction. What if the Empire State Building had been constructed from timber? Michael Green developed a research in which he shows how the Empire State Building could have been built with timber. What if New York's skyline was predominantly made of timber? What would that look like?